Good day to everyone. So now we're going to go to part 2 of our chapter 4 in introduction for probabilities. But in this part, we will look into random variables and probability distribution. Okay, so what is random variables? Okay, so random variables are numerical variable that where the value depends on the outcome of the chance experiment. So again, we met the term chance experiment. Okay, chance experiment. So for each of the chance experiment, okay, we have seen in part 1 where we will get outcome for our chance experiment, okay, and this outcome is being defined by sample space or event, okay. So sample space are just to remind everyone, sample space, okay, are all the possible outcome, okay, from our chance experiment, while event is the outcome of the event that we wanted to see based from our sample space, okay. So sample space is all the possible outcome, where event is the selected outcome that we want, okay. So there are two types of random variables, okay. I think this one also we have discussed in chapter 1 or chapter 2, okay. So we have discrete and continuous, okay. So even for probability, two of these different random variables also is being represented by different probability outcome, okay. So again, this is just a simple revision on chapter 2, okay. So discrete is where you have discrete is where the values, the numerical values that we have is the integer, we can say, okay. Means that we are counting, okay. So for discrete, you need to remember, for discrete, the event that we are interested in is on counting something, and usually it is for discrete type of data, means that like a person, okay, like animals, okay, how many animals that you have, you can't have a continuous values on that, okay. The number of courses that you took for each semester, okay. So these are discrete values, we count, okay, the number of courses you took this semester, let's say 6 courses, okay, 6. So these are counting, okay. So usually it happens on an integer value, okay. We don't have any decimal point of it, okay. And continuous, this is where we wanted to measure something, means, and then usually the values that we see from here is on range. So it can be, let's say this is 1, 2, 3, 4. So when we measure something, we might have values like 2.1, okay, 3.6, okay. An example, okay, so just now the courses, sorry, okay, the courses are discrete, but your CGPA is continuous, okay, continuous, okay, because we wanted to measure, it is for measuring, okay. So courses, this is discrete, number of courses you took is 6, and based from that number of courses, the CGPA you got for that semester is 3.8. So this is on measuring something, okay, on a continuous value, okay. So for example, a counselor plans to select random number of 50 seniors. So we have this random sample of 50 seniors in a large high school, okay. And then the counselor asks the students whether they plan to attend college or in a way in Malaysia to attend university after graduation, okay. So the process of getting the data from the experiment is called the chance experiment, okay. And the sample space for this experiment is that what are different possible answer from 50 students that we might get, okay. Means that it's either yes or no, okay. Yes, let's say we have 3 type of answers. Yes, for those who wanted to go to university after school. No, for those who don't want to go to university after school, or maybe not decided. Okay, so these are discrete measurement because we wanted to know how many students says yes, how many says no, how many says they haven't decided yet. Okay, so this is an example of discrete random variable because we are counting. Okay, counting 1, 2, 3, 4, 5, 6. Okay, so this is an example of a discrete. Okay, discrete random variables. Okay, another example is that we wanted to see how depth is the UTM lake. Okay, so we have a picture of UTM lake here. Okay, we wanted to know, okay, where is the place, okay, the maximum. So let's say we go into the view of the lake base from, let's say this is the land, okay, and then we have the land. So this is so this is the lake part. Let me use blue here. So this is the lake part. So we wanted to know, okay, what is the range or what are the values for certain point depth of the lake. Okay, so we can measure, let's say the deepest point is here. Okay, let's say that is, I don't know, maybe 4.3 meters. I don't know what do we use to calculate depth. And then this is the lowest part of the of the of the lake. So this one may be 0.5 meter only. Okay, so we will get this range measure because we are measuring the depth of the lake itself. Okay, so this is continuous random variables. Okay, so make sure by now you are able to differentiate between discrete and continuous random variable because this is very important. Okay, getting through the rest of the course itself. Okay, so we got into one example. So this is an example where we wanted to see what are the let's say we have a customer coming into a bookstore. Okay, so we wanted to know, sorry, not coming. Okay, the customer that is purchased from an online bookstore. Okay, so we have someone. So we wanted to see for 3 successive customer that log in and make the purchase. Okay, we wanted to know either they wanted to buy the book in print or digital. Okay, so an example, let's say we have a customer here looking at the computer, okay, going into the online book. So we wanted to measure for 3 successive customer in let's say in line. Okay, we wanted to know whether the customer, okay, the customer can choose either they wanted to buy a print book, okay, and the customer right after that is buying digital book, okay, online. Okay, when they, let's say when they add to cart and then purchase the book. So whether whether they're going to purchase printed book or digital book. Okay, so we're going to calculate, okay, for 3 consecutive or successive customers. So we have customer 1, okay, buying digital, let's say customer 2 buying printed. Okay, so there's 3 successive customer. Okay, how we calculate? So it's either the customer will buy, all 3 customer will buy printed book each. Okay, customer 1, 2 and 3, okay, they will buy printed book, or either the customer will the queue, okay, of the successive customer, for the first customer they will buy digital, second printed, the third one is printed. So we have one customer that's one pattern of buying digital printed, and we also have one, okay, customer with the pattern of printed. The first customer printed, second customer digital, the third customer printed again. Okay, and then we have one customer with the pattern of printed digital, 2 customers with digital print, 2 customers with digital, okay, first customer digital, printed digital, and also another 2 customer with printed digital, and we have 3 customers with the pattern of not 3 customers, but 3 sets of customer that buys digital. Okay, so we have one, okay, with the pattern. Okay, these are one group one group that buys digital. So that means that, let's say for this one, we have three groups. So we have digital, 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 digital. So we have three group of customer buying with this pattern. Okay, digital, digital, digital. So okay, so that is what we wanted to. So now, since the possible value of X are only 0, means that there's no pattern like this one. There are no pattern where all three customers buys printed book. Okay, and we have also several pattern of buying one type of one group of customer with that pattern, okay, with that pattern of buying, okay, and then we have 2 and there's 3, okay. So since we are counting, as you can see here, we are counting, okay, how many group of customers that with that buying pattern. So it is counting. So when it's counting, then it is a discrete random variables. Okay. Okay, moving on that one. Okay, so how do we how do we calculate the probability distribution for a discrete random variables? Okay, so how are we going to do the how are we going to calculate, or how are we going to do the probability distribution for discrete random variables? Okay. So for this, for probability distribution model, usually we wanted to see a behavior of the variables in a long run. Means that we analyzed it in a certain time. Okay, and usually for discrete, okay, remember this is for discrete, okay, probability is being represented by p, small p, x, okay, and x here is representing um, the 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 number of possible outcome that we wanted to measure. Okay, example, okay, let's say we wanted to see a certain values of event with 2, so we usually write it as p in the bracket x equal to 2. Okay, so p5, okay, also denotes that the x number is 5. Means that your x, the possibility of that event happen is 5. All right. Okay, so each of these will be given, each of the values, okay, is associated with the possible x values, okay. And then the common way for us to see this is by having a table histogram or looking at the formula itself. Okay, so for example, okay, so we wanted to see, okay, in this place called Wolf City, okay, there is a regulation that no more than 5 pets, okay, 5 dogs or cats can be in a certain household. I mean, okay, for animal lovers, the maximum number of cats or dogs that you can have in a house is 5. Okay, so that's mean our x here, okay, our x here is the number of dogs, okay, that is randomly selected. Okay, remember, when we are talking about probability, we are not going to investigate every house in Wolf City, but we're just going to select few random houses in the Wolf City to see if they have any cats and dogs, or cats or dogs in their place. Okay, so now they wanted to estimate, okay, they wanted to estimate what is the probability, okay, let's say in another 5 years, the value of cats and dogs in a certain household. Okay, so based from their survey, they sees that there is a probability that 0.6 household does not have any cats or dogs. Okay, and then there's a probability of 0.31 that they will have one, okay, one cats or dogs in a certain household. Okay, 0.2 with 2 animals in their house, cats or dog. Okay, and then 0.3 with the probability of 0.13 is the probability for having 3 cats or dogs. 0.06 for 4, okay, and 0.03 to have the most number of 5 cats or dogs in the household. Okay, so this is what we call as a discrete probability. Okay, and we can also display it with a histogram like this. Okay, so for discrete probability, okay, this is one thing that you need to take note. Okay, your x-axis, okay, usually is represented like this. For discrete, remember, it's not counting, it's not measure, so it is for counting. It is not for measuring, means that usually it is integer number. Like say, number of pets 0, 1, 2, 3, 4, 5. So for this, for discrete probability, okay, you see, we don't measure range. There's no range. I mean, there's no one have like 1.5 pets in the house. Okay, so it's usually integer number. Okay, and then usually it is being represented when you do your Excel, when you do your axis, when you do your graph. Usually, one bar is or one interval or one column, okay, in your histogram is representing 1. Okay, so everything here is 1. All right, so you just need to take note of that. Okay, you don't draw it like let's say this is 0, 1. Okay, so the example 2, 3. So you don't put the values in between the panel, okay, but it has to be at middle of the panel, because we are saying that the whole bar here is representing one thing, one count. Okay, one count. Okay, so remember, you need to take note of that. Okay, so that's different. All right. Okay, so what are the properties for discrete probability distribution? This is just the same with the one that we've discussed in part 1. Okay, the p-value must be between 0 and 1. Okay, so just like this one. Okay, you see the values is between 0 to 1. Okay, the closer you are to 0 mean that there is less likely that this will happen, means that there's not so many household with 5 cats or dogs. Okay, the most we can see here is 1, meaning that most house, they have at least one, or they have the most one cats or dogs. Okay, so the nearer it is to 0, because remember I said previously 0 means it is not likely, or means that you don't have it. Okay, there's no values. Okay, 1 means that you will have it. So the nearer you are to 1 means that the probability is much higher. Okay, and the total sum of all the probability must be 1. Okay, just like this one. If you add up all of this, since the rules is 5 until 5 maximum cats or dogs, so when you add up 0.26, 0.31, 0.21, 0.13, and 0.06 and 0.03, you get 1. You will get 1. If you don't get 1, okay, let's say total you get 0.8, that means that there are possibility that you have household with more than 5 cats and dogs. Okay, so you must not get is the total number of the probability of the event that you want to look in, your probability of your event space, or of your of your sample space must be 1. Okay, the probability of all a discrete value that you can going to calculate will be 1. Okay, so an example here. Okay, so based on the dogs and the dogs and cats example, so the question, if you are wanted to know what type of question that you might ask, okay, so it will ask, what is the probability that that a randomly selected house in Wolfgang has at most 2 pets, means that the maximum number of pets. Okay, the probability, we wanted to know the probability of people having the most 2 pets are 0.78. So how do you get 0.78? Because this is the probability for not having any animal, cats or dog. This is for having at least 1 cat or dog. Okay, and then this one is for having 2. So because we say that at most 2, okay, so you look at the symbol here. Make sure the symbol that you use is x less or more or equal to. This is very important, okay? This, to understand this is very important. So that means that the most number that you get is 2. So you add up all these 3. Okay, so you get 0.78. Okay, next one. What is the probability that a randomly selected household has less than 2 pets? So again, you look at, so you look at the symbol. So this one is x less than 2. It's not less or equal to. So you see the result is different. This one is only 0.57. Why? Because we only get the numbers, because they say less than 2 means that the most number of house with 1, the probability of house with one, at least one pet is 0.75. Okay, so we only calculate the probability of 0 and 1. Okay, this from 0, this from 1. All right. So next example, what is the probability that a randomly selected household in Wolf City has more than 1 but no more than 4? Okay, so that's the rule. They have to, okay, means that we wanted to know how many house have more than one pet. More than one means that it should start with 2, okay, but no more than 4. The maximum is 4. You look at the symbol. More than 1, x value is more than 1 but less or equal 4, so you get 0.4. Okay, because this is from the probability. We only wanted to consider these 3 probability rules. Okay, so this one. So this type of questions, okay, this is included in your midterm. Okay, chapter 4 is included in your midterm. So usually this is the challenging part of midterm exam. Okay, based on my experience, every year chapter 4 is the one that will see whether you do good or not in your midterm exam. If you are able to answer chapter 4 question, you are, you know, you likely have a very high score, okay, for your midterm. Okay, I've seen this in several session already. All right, so okay, so that's okay, so that is for discrete probability distribution. Okay, now next, okay, since we have discrete and continuous, so next we need to see on continuous variables. Okay, continuous variable, okay, you need to remember the main difference between continuous and discrete is that continuous, it will take many values. Okay, means that the x values is based on the interval number. So your x can be in between, you know, certain values. It might be between 90 to 100. So it has a certain range that you need to consider your values in. Okay, so that is continuous. So if you don't have a definite values, then we actually going to consider, okay, all the values from the integer. Okay, not, okay, means that this column, okay, let me make it bigger. This column here does not represent one certain value, but it represents, so for this one, it may be 200 to 205 maybe. I'm not sure because so that means that your x value might be in any of this range. Okay, so that's the main thing about that's the main difference between continuous and discrete that you need to remember. All right, so for discrete, usually we use what we call as a density curve. Okay, the density curve, okay, means that it's already been auto calculated, the density curve, okay, and it's being represented by fx. So remember, px is for discrete, fx is for continuous. So you need to remember that. Okay, means that for fx, we observe the value that is under all the curve. Okay, meaning under all the possible curve that we have. Okay, let's say for this one is all under this possible curve. Okay, all the values under the curve needs to be considered. Okay. Okay, so this is what we call as this is what we meant by a density curve. Okay, the density curve itself. Okay, Okay, so we are going to calculate what is the probability under the density curve, under the curve itself. All right, so this is the density function. I mean, as far as I remember, there's no need for you to memorize this formula. Okay, it's not related. Okay. Okay, so again, the properties or the rules of continuous distribution, it's the same. It's similar to discrete. Okay, usually the value will always more than zero. Okay, this is a bit different compared to discrete. Okay, for discrete, usually the p values is between 0 to 1. Okay, but for this one, the fx value is always more than 0, more or equal 0. Okay, and the total number, we cannot really specify whether we can have 1, okay, in fx. Okay, but the total area of the density area, oh, this is not a nice graph. Let me redraw this. Okay, so based on the density area, the density curve that we have, okay, so all the values here must equal 1. Okay, it must equal 1. Okay, so you need to remember that concept. All right, so for an example, okay, this example is a bit different because it does not shows you on curve. Okay, this one is going just a simple example on a straight line. Okay, so let's say we have a clock that will able to process a certain type of form. Okay, where the density curve means that the density curve for this clock is 0.5. Okay, so okay, in between 4 to 6 minutes. Okay, so we have this is okay, in between 4 to 6 minutes means that um, uh, we are not saying that, okay, for discrete we might say that this is for 5 minutes flat, but we don't want to say that it might be okay, the clock might be able to do it in 4.9 minutes or 5.5 minutes. Okay, but then the density or the probability from 4.1 until 5.9, so this is 5.9, okay, because it's less, it's not equal, it's between 4 to 6. So we are going to say that the probability of having 0.5 probability, the clock might be able to finish it from 4.1 until 5.9 minutes. Okay, so this is the range. Okay, this is the range that the clock will be able to finish processing the application. Okay, so it asks what is the probability that it takes more than 5.5 minutes to process the form. Okay, we know that the density, the probability is 0.5. Okay, so this is the probability, the density, sorry, we call it as a density. Okay, and since the question asks what is the probability if if she can process it more than 5.5 minutes, that means that we are only interested on this part from 4.5. Okay, since we are saying that this 0.5 density is for in a way 5 minutes, so we wanted to know what happened if she process it more than 5. So 5 minus 5, 5.5 minus 5 is 0.5. So we are only interested in this part, so that's why we use 0.5, the density. This is the minute. Okay, on the later part of the minute, so the probability that she'll be able to finish it more than 5.5 minutes but still less than 6 minutes is 0.25. Okay, so this is just a simple line density or line curve that you will see. Okay, usually, but it's very seldom for us to see this different type of problem. We just wanted to show you to make sure you understand that um, uh, we are only interested on a certain part of the density curve. Okay, so there are other density curve. This is a straight line density curve. Okay, so there are other density curve. Okay, okay. So if you have this, is you will most frequently see this type of graph later. Okay, so you need to remember, okay, the probability that is being given is not on a specific range, meaning that usually when we have to know the probability of, let's say you wanted to know what is the probability of x, where x is in between A and B. Okay, so you need to understand what is the probability first of the upper limit of B and the lower limit of A. So we will be able to get the, so because we are only interested in this part, so this is this is B, this is A. Okay, we're only interested in this part, not the whole part. Okay, so for us, in order for us to know this, we need to know what is the probability of B, the whole part of B, the whole part. Okay, remember just now, the probability is usually under the curve. Okay, so in order for us to know what is the probability of x, where x is between A and B, first you need to know what is the probability of B, the whole probability of B, the upper part of B. Okay, then we need to know what is the probability of A, of the lower part of A. Okay, A. So you need to get this value. Okay, so the probability of x between A and B is where you minus probability of B and probability of A. Okay, don't worry much about this. I think you understand this more when we get into the exercises or the examples. Okay, you just need to remember this concept. Okay, you need to remember this concept. For us to get the value of, x between a certain number, we don't just get into, we don't get straight away from the graph. We need to do this type of solution. Okay, you need to do this type of solution. You need to find what are the probability of B, and you need to find what is the probability of A. So B minus A, then you will get the probability between of value x, where it is between A and B. Okay, so you just need to remember that. All right, so these are other type of distribution. Okay, for this class, okay, specifically for this class, you will use T, F distribution and chi-square distribution. Okay, for this class, okay, we're only going to use these three type of distribution. Means that this is how the graph will shape, the shape of the graph, the probability shape of graph that we will use. Okay, so we will see this later. Okay, so it's either three. So you need to make yourself familiar with the three tables in the e-learning. I have uploaded statistical tables. Okay, so you just need to make sure that you are getting familiar with this three table. Okay, so later we will see this. Okay, so that's the end of part 2. Okay, so I'll see you guys again in part 3, where we will discuss more on the continuous distribution probability. Okay, thank you.